My PhD is in investigating active acoustic cloaking. When sound waves hit an object, they reflect back in a different direction. Just like if you make a loud sound in a cave, the sound scatters off all the walls and eventually comes back to you, meaning you hear an echo. When trying to reduce noise from large ships, which could minimise the impact on marine wildlife amongst other applications, these reflections could exacerbate the problem, and therefore I'm investigating ways to stop an object from reflecting sound, or acoustically cloaking it. I'm using microphones to measure the reflected sound waves and loudspeakers to cancel them out, exactly the same way that active noise cancellation headphones work. My academic supervisors and I decided that the best way to approach the challenges set by BAE Systems was to use computational simulations to better understand the physics, before designing experiments to investigate control methods. We used the unique facilities at the Institute of Sound and Vibration Research to make incredibly precise acoustic measurements, which we found accurately represent the behaviour of these platforms at full scale. My project is funded as part of an EPSRC Prosperity Partnership programme entitled Intelligent Structures for Low Noise Environments. To protect marine wildlife, shipbuilders have to meet certain noise criteria on every vessel they build. Some programmes are now considering the use of underwater drones to measure the noise created by a ship. But the acoustic scattering from these underwater drones means that the measurements are often inaccurate. Using a system like the one we've developed, the drones can be acoustically cloaked, resulting in more accurate measurements and less impact on the oceanic environment. The support we get from BAE Systems has been invaluable. We have regular meetings with our technical supervisors at BAE who make sure that the research remains on track and relevant, which often presents us with novel challenges to solve. The opportunities that BAE has given me have been really beneficial, from giving me access to full-scale ships to test my research on, to inviting me to outreach events where I can develop my communication skills and hopefully inspire future engineers. The highlight of my PhD was going out to sea on a Navy ship to test the research at full scale. This was a huge learning curve, as most of my research had been lab-based up until this point, and to build a system on a 200-metre long ship out in the open sea created a very different set of challenges. It was a fantastic experience, and I enjoyed every minute of it. I'm delighted to have been awarded the BAE Systems iCASE award this year. I've been following the research of the other shortlisted candidates, and they're all doing fantastic work, so for the panel to award me the prize is very humbling. The iCASE programme is fantastic. The ability to do your research without having to worry about other constraints like timescales or funding is great, and allows us to make much better progress on the research. I recommend it to anyone considering an industrial-focused PhD. Active control has seen huge advances in the last 20 years or so. As computers get smaller, faster and cheaper, active control systems can be applied to all sorts of situations. Luxury cars, airplanes, open plan offices, ventilation systems, etc. all could use active control systems. My great-grandfather was a submariner on HMS Utmost, and sadly him and all of his crewmates lost their lives at sea. That really brings home the importance of giving our armed forces every advantage we can, and it's one of the benefits of working with BAE Systems is the knowledge that my research will be directly used in real-world applications to help defend the UK.